Welcome back. Here we are, Just Math, y'all. And we are on our last video. Hopefully. We'll see how it goes. Okay, so this equation that we're going to solve, we're solving exponential equations using logarithms. Now, this one is different than all the others. This one has variables on both sides. So this one is much trickier in the solving part than the others are going to be. So let's get started. We can't isolate the exponent part because we have two of them and they are technically on each side of the equation. So we're going to leave that there. So step one is pretty much done. So step two is going to be, again, like we've been doing, is to make the natural log of both sides. All right, so we'll do that. So I'm going to do the natural log of 7 to the 5x plus 6 is equal to the natural log of 5 to the x minus 2. All right, so now the next thing I'm going to do is what we've done before, is we're going to move our exponent to the front. All right, we'll do that for both of them. This is different because, again, we have two variables. We have variables on both sides of our equation, which makes things different. So we move the variable to the front with the exponent. Okay, so now here's where it gets different. Okay, step 4, we're told to solve. Solve for the variable. Okay, well, we've got two of them. They're on opposite sides of the equation, and somehow or another we got to get them together. We've got to get the variables on the same side, and we've got to get the numbers on the other side, and we've got these natural log things. So here's what we're going to do. First thing we're going to do is we're going to distribute the logs. Okay, we're going to distribute. Log 7 and log 5 are just numbers. So we're just going to distribute. And so this would give me 5x natural log 7 plus 6 natural log 7. And on the other side, we're going to get x natural log 5 minus 2 natural log 5. So I distribute. Okay, so now what we're going to do is we're going to get our like terms on one side. We're going to get our like terms on one side. So variables are going to go on one side. Those two are going to be on one side. And then the others, which are the numbers, are going to be on the other side. So I'm going to get variables on one side and numbers on the other. So now I'm going to do this. I'm not going to write it all down. I'm just going to do it. So hopefully you're advanced enough in math that you'll pick up on what I'm doing here. So I'm going to have 5x natural log 7 minus x natural log 5. And then on the other side, I'm going to have a negative 6 natural log 7 minus 2 natural log 5. So think that through. Stop the video. See if you can't figure out what I've done. I think you can. But that's what we did to get the variable on one side. Remember, the variable is x, and the numbers on the other. Okay, so now here comes a little trick that we haven't ever done before. These x's, we've got to combine these as like terms. So in order to do that, we're going to technically factor out an x. We're going to factor out an x, and that's going to give me x is factored out, and that's going to give me 5 natural log 7 minus natural log 5. And I'm not going to do anything to the other side of the equation. Okay, now remember, we are solving for x. So we are solving for x. So the next thing I need to do to solve for x is to divide because x is being multiplied by this parentheses. And so I'm going to divide both sides by this big parentheses. And that's it. I'll be done. Divide both sides by this, and x is by itself. And so I'll do that over here. 5 natural log 7 minus natural log 5. And that's it. That is my exact answer right there. That's it. I've solved for x. Now, using the calculator to get the approximate answer, that's a little trickier. You're going to have to use some parentheses in your calculator. You're going to have to mess with your calculator skills a little bit to work that out. Just remember that parentheses are going to be needed if you do a numerator and a log. But you're going to have two sets of parentheses, possibly, and a denominator and the logs. So however you do it, the decimal that you should get, rounded to the nearest hundredth, is negative 1.83. So see if that doesn't work, and I'm going to check my answer to make sure it's right. Okay.